Okay, so February 5, Monday, and we start our class. And today we start linear equations. Okay, so linear equations. And we will start talking about variables, their notations and stuff, so we're on the same page. So identity equations, terms, factors, constant variables, and coefficients. So let's read that fairy tale story. So before we work with equation to solve problems, we need to understand the basic concept and terminology of equations. In mathematics, we use symbol equal to show that quantities are equal to each other. We write the statement 5 is equal to 2 plus 3. And here you have 5 equals 2 plus 3. This symbolic statement is called an equation. Okay, an equation is a symbolic statement that two expressions or quantities are equal in value. An equation may be true or false. Okay, so to verify that the equation is true, so what we have to do? We have to find value of the equation on each side of the equation equal sign. And then we compare one to each other, and if they are equal, equation is true. If not, equation is not true. Any questions? Pretty straightforward, right? So let's try this. So what we have, 3 times 8 equals to 24. So if I multiply 3 times 8, what I have? 24, right? So 24 equals to 24. It means equation A or statement A is true equation. Okay, what is that? 12 minus 3 is what? 9. 2 plus 7 is what? 9. 9 equals 9, so we have again true equations. Okay, try this one. Try this one. So if you look at first one, left side, minus 5 times minus 3, what is it? 15. So 15 is not equal to negative 15. What are you looking for? So the first equation is not true. What about the second one? 15 minus 3 is 12. 2 times 6 is what? 12. So 12 equals 12. The equation is true. Good? So to solve an equation, what does that mean? It means to find the missing number that makes the equation true. That's what we mean when we say solve equation. Variable, that's the letter that represents an unknown or missing number in an equation. It can be any letter, right? Anything. So let's have a look what is here. Find the value of variable that makes the equation true. So A, x equals to 3 plus 8. So left side is what it is. So 3 plus 8 is what? That's it. 3 plus 8 is 11. We solve it. B, 18 over 3 equals to n. So n is what? 6. C, y equals 3 times 4 minus 5. So what we do, we multiply first. What is that? 3 times 4 is 12, minus 5 is what? 7. Okay, good? Pretty straightforward. We did this before here or somewhere else. Okay, go for 1, 2, 3, do it. Okay, so the first one, m equals minus 2 plus 9. What is it? 7. Second one, minus 18 divided minus 2 equals to p. So p is what? 9. 3. 5 times minus 3 plus 8 equals to y. So 5 times minus 3 minus 15 plus 8 equals to y. What is that? Y equals minus 7. Good? So, more terminology. What is symmetric property of equality? A property of equality that states if the sides of an equation are interchanged, equality is maintained. So what it means, for instance, here, the original was minus 7 equals to y, right? What I did, I interchanged the sides and equality stays the same. Terms, algebraic expressions that are single quantities or product or quotient or quantities. So terms, for example, minus 2 plus 9, those are terms. 5 times minus 3, that's term. Plus 8 is term. Okay, symmetric property. One thing, one moment. Okay, symmetric property. If the sides of an equation are interchanged, equality is maintained. That's what we just discussed. Symbolically, if A equals B, then B equals A, where A and B are any real numbers. Okay. So now let's talk about terms. To identify terms, separate an expression into terms by an identifier addition or subtraction signs and that are not within a grouping. Right? The sign of each term is the sign of the preceded term. So 3a plus b, two terms. Right? So terms separated by signs plus or minus. Okay? Understand? So 3a plus b, that's two terms. One term is 3a, the second term is b. Now, 3 times a plus b, it's one term. Why? Because I have what? Product here. I take 3 and multiply on what? Parentheses, right? Now, quotient, 3 divided on a plus b, and this thing is negative. So that's one term. Why? Because, well, frankly, multiplication and division, that's the like what? Yeah, that's the opposite. Good. Well, we consider part of equation to be term if it's separated with plus or minus. So this three examples showing you that here you have two terms and next two, that's only one term. Okay. So let's identify terms. So let me take a highlighter and we will do. So for A, where is my pen? How many terms we have? 2, 3x, and 5. For B, that's the term, that's the term, that's the term, and this the term. Yes? Guys, legit? Everybody agree?
Yes.
So here,
So it's 4 terms?
1, 2, 3, 4, yes. Absolutely. Absolutely. It's either one or more. Here you have what? One term. Here you have 1, 2 terms. Okay, try this one. Yeah, let's do it together. So first, how many terms you have?
2.
Are you sure?
Now that you're asking me, it's not.
What it says here? One term, right? So what do you have here? Something like that, right? So it is one term. Here you have 2 terms. This one, term,
2 terms.
term, this quotient is term, and term, 3 terms. So highlighted are terms. Okay, more vocabulary. Constant or number term, a term that contains only number. For example, oops, here was 1, 5, 2. That's the constant term. Variable term or letter term, a term that contains only one letter, several letters used as factors, or a combination of letters and numbers used as factors. So what I have, 2ab, that's the term. It's a combination of constant 2, letter A and letter B. 3x, that's the term. B, that's the term, right? Variable term. We're talking about variable terms now. Okay? Now, what is coefficient? Coefficient, each factor of a term containing more than one factor is the coefficient of the remaining factors. The numerical factor, also called the numerical coefficient, is often implied when the term coefficient is used. So what is that? 2 coefficient, 3 coefficient, 4 coefficient, right? 2 coefficient. Okay, numerical coefficient, yeah, we just went through it. And here we say, that's we discussed numerical. Each factor of a term containing more than one factor is the coefficient. So, yeah, okay, let's do it. Let's do it. So numerical coefficient, let me take highlighter. This one, right? This one, what is it? 1/3. This one, 2/5. Not numerical coefficient, for instance, here is A, B, right? But most of the time, we refer to coefficient as to numeric coefficient. Right? So what is numeric coefficient here? The first one. What is it? 7. Here, minus.
Minus
Minus 2 over 9. Here,
6.
no,
1 over 6.
1 over 6. 1 over 6.
Has to be does it have to be a fraction?
Well, it is fraction here.
Oh.
You can write as this.
What if I just put 6 though?
It's if you put 6, you imply this.
Oh yeah.
Okay? Good? So let's go and learn how to write verbal interpretation of symbolic statements. In symbolic statements, we commonly use letters to represent missing values. That is, we write, that should be 5. 5 plus x equals 8, or 5 plus y equals 8, or 5 plus a equals 8. The choice of letters is not usually important. The position of the letter and the other conditions of the statements are important. We can phrase a mathematical statement several ways. 5 plus x equals 8 can be stated. What number added to 5 gives 8? So what is happening here? Now we're converting symbols to sentence, right? Why we need that? To solve fairy tale story questions, right? Text questions typically want us to create an equation, right? Or we can say 5 plus a number has a result of a. What is the missing number? Right? So possible interpretation of symbolic statements. So what we're supposed to do to write a verbal interpretation of symbolic statements? First of all, we need to locate a variable or variable terms. Then we examine the operation that links the factors and terms. Right? And then we write a verbal statement or statements that describe all the conditions of the symbolic statement. So let's see. Here I put example with answers already, so we don't we can try something else, but so we have 4 statements. X minus 7 equals 4. So possible answers. A, when 7 is subtracted from number, the result is 4. Okay. What else I can say? If I subtract 7 from the number, I will receive 4, right? Something like that. Now the second, the B, a number divided by 5 is 3. What else I can say? 1/5 of the number is 3. Or 1/5 part of the number is 3. So 2x plus 3 equals 15. What they say, 15 is the result when 3 is added to 2 times a number. What is possible? Possible, for example, like that. When I double a number and add 3, I will receive 15. Possible? Possible. So 2 times x plus 3 equals 14. So if the sum of the number and 3 is doubled, the result is 14. What else can we say? Well, let's leave it like that. So any questions? So that's probably the most tricky part when we solve text questions, right? We need to proper identify what they actually mean. What they actually mean. Translate verbal statement into symbolic statements using variables. So now we do reverse job. So what we're supposed to do to translate a verbal statement into symbolic statements using variables, first we need to assign a letter to represent a missing number. Typically we use X, right? If we deal with time, we use T, right? If we look for a missing number, we can use, let's say, A, right? The selection of the letter doesn't matter. So then identify keywords or phrase that imply or suggest specific operations. So we would add, subtract, right? Divide, multiply, something like that. Translate words into symbols. So let's have a look. The sum of 12, 23, and the third number is 52. So what I conclude from here, how many terms I have? 3 on the one side, right? So what happening? 12 plus 23, and the third number, so I add, is 52. Correct? So when a number is subtracted from 45, the result is 17. So what is that? That is minus, right? So number subtracted from 45. So 45 minus x is 17. Good? Okay, try this one. So the first one, difference states for minus, right? 18 and the number. So 18 minus x is 6. Why not x minus 18 is 6? So difference between 18, it means I what? Reduce 18, right? 2. The sum of 5 and the number is multiplied by 3, and the result is 27. So the sum of 5 and the number is multiplied by 3. So 3 times 5 plus x. That's what I understand. Agree? So what I see here, I see the sum is multiplied, right? So it means I have to add first and then do multiplication. Make sense? So how we do that? We use parentheses. Here, keywords can be examined to identify operations. So for addition, for subtraction, multiplication, and division. We're not going to go through that. Well, if I didn't upload slides yet, I will. So you can print or just go through from there. Right? But many of those words you already have experience with, right? Okay, let's practice. Translate the statement into symbols. How many shells that are each 3 feet long can be made from a board that is 12 feet long? Hmm?
Divide.
We can do divide, but what divide? 12 by 3? We could do that, but I would rather do that. 3 times x is 12. Well, you can do that. It's the same thing. It's the same thing.
But you're looking for that answer.
Well,
On a test.
I take any answer. This or that is fine. As soon as it's correct. Explain the difference between two statements. 4 times the difference between a number and 8 is 24. So what we write? 4 times the difference between number and 8. Difference between 4 times the number and 8 is that's the difference. Okay, understand? So first statement says that we multiply difference between number and 8 by 4. Second statement says that we multiply number by 4 and then we take difference. Then we subtract 8. Okay, simplify variable expressions. More vocabulary. Like terms. Terms are like terms if they are numbers or if they are variable terms with exactly the same letter factors, including exponents. Okay, so to simplify variable expression, change subtraction to addition if appropriate. Right? Add the constant using the appropriate rule for adding signed numbers. The sum is a signed number. Add the numerical coefficient to the like variables using the appropriate rule for adding signed numbers. The sum has the same variable or variables and as the like terms being added. So let's practice. Simplify. So a 5a plus 2a minus a. So what I see here, I have 3 terms. Each of them has variable a, right? So 5 plus 2 minus 1 is what? Good? Oh no.
No.
Why not? What is good then?
It was 5. It said 5.
Why 5? 5 plus 2.
Never mind.
Okay, treat a as apple.
It's good. It's good.
So you have 5 apples, you had 2 apples. How many apples you have? 7. Then you give somebody 1 apple. You have left with 6 apples, right? Okay, this one, 3x plus 5y plus 8 minus 2x plus y minus 12. Here we have 3 different types of terms. We have terms with x. We have terms with y. And we have terms with constant, right? So what we do, we take 3x plus minus 2x plus 5y plus y plus 8 plus minus 12. So what I have, x plus 6y minus, or plus, what is it, minus 4? And finally, x plus 6y minus 4. Agree? So those brackets and minuses inside, that's just the baby steps.
You have to separate. It's separating.
Well, I'm grouping like terms together. Right? So I color coded them. Well, if you don't have colors on you, you can group them in brackets. Right? What's alternative? If you skip that baby steps playing with minuses, you can write like that: 3x minus 2x plus 5y plus y plus 8 minus 12. And result will be x plus 6y minus 4.
You did the same thing, though, right?
Yes. Well, except I didn't play here with plus minus 2. Here I put right away minus 2. Okay? Any questions? Okay, practice that, please. Okay. The first one, 4b minus b plus 6b. So what I have? I have 3 terms. All of them have b, right? With the first exponent. So 4 minus 1, 3 plus 6, 9b. Okay, we good? The second one, 2a plus 3b minus 7 plus a plus b plus 4. So what I have, 2a plus a plus 3b plus b plus minus 7 plus 4. Yes? Pay attention, I considered minus 7 inside of the brackets, right? In between brackets, I put plus.
You could have put like minus on the outside. Minus.
Well, if I put minus on the outside, I have to put 7 minus 4. So it's already changing signs. It can create confusions, right? So I rather put plus in between brackets, and then inside brackets, I consider the sign what is in front of that term.
So you do it all the time?
Yeah, well, let's do it this way. These steps, it can be easy done in mind with practice, with experience, right? But I prefer that you do this way what I've shown you to do, okay? But let's put it this way. If you do it differently without mistakes, so do the way you already know how to do it, okay? So what I have, 3a plus 4b minus 3. Good, gentlemen? Okay. Simplify by applying distributive property. So what is distributive property? When we open brackets, so 3 times 5x minus 3 times 2, that is 15x minus 6. Good? B. So minus 7x minus 7y plus 21z. Good? Minus times minus gives me plus. C. 3x minus 4. Good? Guys, any questions? Everybody comfortable with those minuses up front? Okay. Do this 1, 2, 3, and when we finish, we take a break. Those are the answers. You have the same? Good? Okay, so let's have a break. What time is that, by the way? 43, no, let's go to 45 and then, what, 15 minutes today? Monday? Okay. Oh, solving, okay, let's have a break. So come back, what, at 11. Let's have a longer break today. So back at 11. Okay. Hey guys, break is over. Any questions so far? Let's continue. So more vocabulary. Linear equation in one variable. An equation in which the same letter is used in all variable terms and the exponent of the variable is 1. So remember till the end of your life that linear equation means this. Okay? So the moment you hear linear equation, you can write something like that. right? That's equation, linear equation. Variable here, x, a, b, and c. Well, actually, it's two. No, I probably this ax equals to b. That's what it is. Where x is variable, and exponent is what, 1. Right? So that's linear equation. A and b, it's numbers. So solution or root, the value of the variable that makes the equation true. So in this case, is this, right? So basic principle of equality. To preserve equality, if we perform an operation on one side of the equation, we must perform the same operation on the other side. So what we did here, we did ax divided on b, on a, and b divided on a. So what we did, we performed same operation on both sides. We divided left and right side on the same number a. Of course, a here is not 0. And if it is, we have no equation, right? Isolate, to perform operations so that variable with a coefficient of 1 is by itself on one side of the equation. Here it is. We isolate it, right? Addition axiom. The same quantity can be added to both sides of the equation without changing the equality. Yes. Well, it's just coincidence that they are the same. So for example, if I have 5x plus 3 equals 17, I would do what? Let's make it 2. So it will look nice, right? So what I do, 5x equals 17. Actually, addition axiom, the same quantity can be added on both sides. So what we do here, what we add? Minus 2, right? So plus 2 plus minus 2, 17 plus minus 2. So 5x equals what? 15. And x equals 15 over 3. Or to isolate, probably the best would be like x plus 7 equals 3. So x would be 3 minus 7. That's isolate. That is solution. Okay? So it's very thin difference. Sometimes it's more obvious, sometimes it's not. Yes. What do you mean? 3 minus 7 is minus 4. Yeah, that's the next. 3 minus 7 is minus 4. At least it was this morning, right, guys?
Well, x equals 15 over 3x over 15. 5.
Oh, 5, yeah.
No.
Oh, yes, I already divided. So that's isolate. This, that's isolate. That's solution. Okay. Any more questions? Okay, so to solve, locate variable, identify the constants that associated with variable by addition or subtraction, add the opposite of the constant to both sides of the equation, right? We did it many times. So x plus 4 equals So technically what we're doing this. We add same number to both sides. That's technically what we're doing. But with experience, right? So what we say, we transfer that to other side. And that's what it is. Good? Okay, do this one. X equals what? What I 4, right? So what we just did, well, minus 4. We skipped all these steps. Technical steps will look like that. What I'm doing, I'm isolating X with coefficient 1 on one side and everything else is on other side. So that's isolated, that's the solution. Good? But what we do, we just mentally transfer that here with opposite side and perform the operation. That's it. Okay, do this A, B, C, D. Take a few minutes, please. Say anything. So what I have for the first one, X equals minus 3 plus 7, X is 4. For the second one, X equals 5 plus 2, X is 7. For the third one, X is 8. Oh, actually,
How is the first one 4 if it's equal to -3?
but plus 7.
But 4 minus 7 is 3.
4 minus 7 is negative 3. Right? So, what is it? Good? So, solve linear equation using multiplication axiom. What is multiplication axiom? Both sides of the equation may be multiplied by the same non-zero quantity without changing the equality of the two sides. Of course, it's not zero, non-zero, right? This axiom also applies to dividing both sides on an equation by the same non-zero quantity. So we use that when we have fractional coefficients, right? To make life easier. So multiply, divide, stuff like that. Okay, solve the equation. So technically here is what? Yes? Or we can say this. Can we do that? Of course. This one. Yes, that's what I think. Yeah, it is. Well, recall fractions. Right? Okay. You have 4 of them. Do it. Okay. So here, 1. What is it? X is minus 65 over 5. X is negative what? 15, right? Yes, no? No? Why not? Huh? 30. Okay, good. Thank you. 30.
That are you testing us or you?
Just sometimes yes, sometimes no. Well, I'm thinking something else.
Say all the time, like, right?
12x equals 108. Because I want you to participate.
Yeah.
You know what I mean? So here, if I don't have calculator, what I can do? What is the answer? 9, yeah. So 108 over 12. What I can do, 54 over what, 6? It's 9, right? Good. Or even, let's say I forgot multiplication table, what else can be done? I can do what? 27, and that is 9. Right. Okay, let's do this one. So the first one, what is it? 0, 4. Or if I don't have calculator, what is it? 4 over 10, right? 24 times 10 over 4. What is it? 24 and 4. No, 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 no. 12, 6, right? Good. 24 divided 0, 4 is 60. Good. The second one, x is negative 14.4 over 1.2. Well, I would take calculator here. It's 12. What? Oh, it's 28. Why I put 24? Tell me. Because it's convenient, huh? Yeah, because it's convenient. No, that's already my booba. $28. So 28. What is it? 7? And it is 70. But 24 was right as well, right? I mean, if you take, yeah, I did math right, right. Okay. Next. Solve the equation. So what I do, technically, I multiply by 4 two sides, right? So n is what? 28, yes? So here we can do that. Or do it mentally and you would have like this. But nothing wrong with that step, especially if it's something new for you or something. So try this too. Wow, many more. We have good, be good for 2 classes to play with. Okay, so the first one, 1 over 5 n is 3. So this one is easy, right? N is 3 times 5 is 15. It's easy. Let's do the second one. This one, it's not difficult, but it's easier to make a mistake here. So I suggest we do this. Multiply on the reciprocal, right? Well, you can use the calculator, but you don't often have access to calculator. And believe me, it's good to do some basic stuff with your head, not only the calculator, right? Well, You can divide 2 by 3, right? But why? So now look at that, what I have. Here I have 1 times n equals 6 and 2, simplify, and it is 9. Right? So with fraction, I suggest you do step by step in order to avoid possible mistakes.
Or you didn't say two.
Huh?
The two should be a one.
Where is 1?
Remember here,
Why 1?
cross it at two and put it at
Oh, it's 1. Here. Yeah, I used it as well. I use that as well, of course. So 3 times 3 is 9. Okay? So solve the equation. Well, here is basic stuff. I divide on -1 both, right? Or multiply. Okay, try this 1, 2, 3. So 1, 2, 3. Correct? Any questions?
why is number
Well, both sides has minus. So I either multiply on -1 each side, right? Or I can divide on -1, which is the same thing in this case. Okay. So to verify or check the solution of equation, substitute solution in place of the variable in the original equation. That's what I say all the time. Analyze your answers, verify your answers, right? Perform all the indicated operation on each side, yada yada. If solution is correct, the value on the left side, of course, should be equal the value on the right side. Okay, so solve linear equation with like terms on the same side of equation. Now we what? We complicate more and more, right? So we have to combine first, so like terms, right? And then we solve equation. Okay. So what we have? 4, 5. Oh, no. 3. Come on, where we are. That's 4x minus x is 3x, right? Equals to what? 50. And then technically we have to what? Divide both sides on 3. And that's the result, right? Do this too, please. So what we have, the first one, 9x minus 4x is what? 5x equals 70 plus 15 is 85, right? So what we have to do technically, divide both sides by 5. So x is 17. Second one, 6x minus 10x minus 4x equals minus 24 plus 24 is minus 20, right? So what we do, we divide both sides on minus 4. So x is any questions? We good? Next. Solve linear equations with like terms on opposite sides. So identify like terms and determine which term of or terms should be moved to create the equation with like terms on each side. Add to both sides of the equation the opposite of each term that is to be moved. That's addition axiom. So other words, what we say, we transfer from one side to another with changing sign, right? That's already known fact what we use. Combine like terms on each side, solve resulting by using multiplication axiom. Okay, what do we have? Okay, let's start with A. 2x plus 4 equals 8. So technically I have to add minus 4 to both sides, or what? Move 4 to other side with opposite sign, right? Every time I cross the border, which is equal sign, what I do? I change sign to opposite, right? Now what I do? I divide by 2 both. Good? Gentlemen? B. So 9 minus 4x equals 8x. So this time I take 4x to other side. So technically, what I have to do, here I had plus minus 4, plus minus 4. Here I had plus 4x, plus 4x, right? So 9 equals 8x plus 4x. 9 equals 12x. And here I divide on what? Well, actually on 12, right? No, not like that. Opposite. Not 12 divided, but divide by 12. So when I have 9 divided on 12 equals x, now I can simplify what? 3, 4. So 3 over 4 is x, or x equals 3 over 4. Good? So do this one, this too, actually. first one, 3x plus 9 equals to 15. So what technically I do? I do this, right? And I have 3x equals to 15 minus 9. Or what we say, we transfer 9 with opposite side sign to other side, right? But that's what in reality is happening. So 3x is what? 6. Now we divide on 3 both, and we have this. The second one, so again, we transfer 3x to other side, changing sign. It was negative, became positive. It was positive, became negative. That's what I mean.
So adding,
What?
you're moving to the other side.
Yeah,
So
well, I still adding, but negative 9. Yeah, here we technically what? Divided by 10, both sides. Okay, gentlemen? Well, I suggest you still practice at home many, many times. Let me see where we have lots of things to do. Let's do it. So sorting the terms, applying the addition axiom to move terms in the quotient in equation so that like terms are on the same side of the equation. Well, that's what we did, right? So when the variable is eliminated in solving an equation, we examine the resulting statement. A true statement indicates the solution set is the set of all real numbers. We call this type of equation an identity, right? A false statement indicates the equation has no solution. So identity, that's the equation for which the solution is all real numbers. So let's see what it is. So 4x minus 3 equals 3x minus 3 plus x. So what we do? We transfer everything with x to the left, for example. So 4x minus 3x minus x equals, what is it? Minus 3 plus 3. So what I have, 0 equals to 0. So that is identity. That's example of identity. If result is true, I have identity. So a solution for this equation, it's entire real set. Okay, let's have a look. What is B? 3x minus 7 equals x plus 2x minus 11. So 3x minus x minus 2x equals minus 11 plus 7. So 0 equals what? Minus 4? It's not. So how we call that? No solution. So no solution.
zero,
What is that? It's not equal.
like 0.
Oh, you mean like this?
Yeah.
Well, this sign used in computers to make a difference between letter O and 0. Sometimes you can do this. You can find that as well. In math, that's empty set. So set when what has no, what has nothing, it's empty. No components. No, not no solution. Here is no solution because it's not true equality, it's false, right? So B has no solution. A is what? Identity. Okay, try this too. Okay, what is 1? So 7x plus 2 equals 2x minus 6 plus 5x. So 7x plus 2. What is possible to do? We can what? Combine here, right? And then I have 7x minus 7x equals minus 6 minus 2. So 0 is not equal to minus 8. So verdict, no solution. Okay, the second one,
Why is there no solution?
because it's not true equality. 0 is not equal to minus 8.
So it should have been -8, -8.
Yeah.
-8.
Oh, 0 and 0. Left side should be equal to right side. Or some number, or x equals to something like it was before. But now we're looking at examples when we have either identity, which is x can be any number, or no solutions. So what I have here, let's move everything, let's go step by step. So here's minus 6, right? 9x minus 11x, so what I have? Minus what? 2x, right? Minus 6. What I have 0 equals to 0. Well, let's do steps. So minus 2x plus 2x equals minus 6 plus 6. So 0 equals to 0. So identity. Okay? Good? In math, we say this. X belongs to all set of real values. But that's a little out of scope of this course. Okay, an equation can be solved two ways. First, by isolating the variable terms to the left, by isolating the variable terms to the right. So we understand that both are, well, same thing. Why we need that? It happens that subconsciously we more accepting positive values than negative, right? So that's what it is. Let's have a look. 9x plus 2 equals 6x minus 10. So if I make it to the left, I will have this, right? So 9 minus 6 is what? correct? So if I do, so 9x plus 2, 6x minus 10. So 2 plus 10 equals 6x minus 9x. So 12 equals minus 3x. Oops. You see, it's a habit. Okay? Good? Same thing. So now you decide what is more convenient to you. Both provide same answer. Try this one. So transfer first time to the left, second time to the right, and see what happens. Oh, moly. Something. Okay, so what we have? 4x minus 3 equals x plus 12. So 4x minus x equals 12 plus 3. So what is it? 3x equals 15, x equals 5. 4x minus 3 equals x plus 12. So minus 3 minus 12 equals x minus 4x. Minus 15 equals minus 3x. 5 equals x. So the left side is more pleasant, I guess, right? Why? Because we don't have to play with those minuses all the time. Okay, guys, I forgot my memory stick in the computer in the office. So take this too. I quickly come back because we need recording, right? So Okay, so what we do in reality when we solve equations, I quickly analyze what I have, 7 and 6. So 7x minus 3 equals 8 minus 6x. If I transfer 6 to that side, I have positive numbers, right? So what is that? Equals to 11, right? Correct? Now this one. So what is that? Minus 5x minus 2 equals 7. No, 10. Seven plus 3, 10 minus 2x. So here it doesn't matter. Let's do here minus 5x plus 2x equals 10 plus 2. And then minus 3x equals to 12. X is minus 4. Okay. Okay, guys, let me see what is next. I will leave it for the next time. So parenthesis, next time. And it's done for today. So see you Wednesday, right?
Wednesday's quiz is on
Vectors. Vectors, yes. So Wednesday quiz is on vectors.